The next examples I'm using for finding quadratic equations given its roots and zeros will involve both the positive and negative form of roots. The first one being radical roots, the second one being complex roots. In both cases, I should expect to get conjugate factors. Let's start with our first example where I go x equals 3 radical 2 and x equals negative 3 radical 2. If I generate my first factor, I will come up with x minus 3 radical 2. And as I generate my second factor, x plus 3 radical 2, don't forget that this is supposed to generate a quadratic equation, which these were the roots, and so I need to set that equal to 0. Because I do have my conjugate factors, I should expect the middle terms to cancel out. And when you're comfortable, you can skip doing the outside and inside terms. But because this is practice, we'll do the first term, which is x squared. We'll do the outside term, which is going to generate 3x radical 2. We will do the inside term, which is negative 3x radical 2. And then when I multiply the two last terms together, the negative 3 times 3 will be negative 9, and radical 2 will be radical 4. So, as I stated before, the two middle terms should cancel each other out. But while I'm simplifying, I need to remember that negative 9 is actually being multiplied by 2, and so I can come up with the final equation of x squared minus 18 equal to 0. Moving down to our second example, we get x equals 9i and x equals negative 9i. Generating our first factor of x minus 9i and generating our second factor, x plus 9i. Those two factors will be multiplied together and equal 0. Yes, I have conjugate factors, but I would actually have our two complex conjugate factors because they involve I, where I happens to equal the non-real value of the square root of negative 1. So, if you feel a need to work out all the terms, your first term will be x squared, your outside term will be 9xi, your inside term will be negative 9xi, and your last term will be negative 81i squared. Because the middle terms cancel out being conjugates, I will have negative 81i squared yet to be simplified. And I say it has to be simplified because I need to remember that I squared, which is right here, equals negative 1. So negative 81 will be multiplied by negative 1, and I can come up with a final quadratic equation of x squared plus 81 equal to 0. Now before we move on, I want to remind you of the difference of two squares. The difference of two squares is generated when you go a minus b times a plus b and come up with a squared minus b squared. In this particular problem, we are doing the sum of two squares. I have an x squared, which could be x quantity squared, and I have an 81, which is 9 quantity squared. What happens is, when you try to find roots of a squared plus b squared, you're not going to find them to be real. The only kind of roots that you can get are complex conjugates, which means one of them is going to be a minus bi, and one's going to be a plus bi. And there you go.